deep learning. The term itself evokes images of complex neural networks and powerful artificial intelligence. But what exactly makes deep learning? It's a question many ponder, and the answer lies not just in the number of neurons, but in the elegant architecture of layers that allows these systems to learn in increasingly sophisticated ways. Forget simple, single-step processing. Deep learning is about building a hierarchy of understanding, where each layer refines and transforms the information it receives. At its core, deep learning is inspired by the structure of the human brain, though it's a simplified abstraction. We're not talking about replicating biological complexity, but rather harnessing the power of interconnected processing units arranged in specific ways. The crucial element that distinguishes deep learning from other machine learning approaches is this deliberate, multi-layered organization. Each layer acts as a stage, progressively extracting more meaningful features from the raw input data. Imagine you're trying to teach a computer to recognize a cat in a picture. A shallow network might struggle to grasp the nuances. A deep network, however, begins by identifying very basic elements in its initial layers: edges, corners, simple curves. These fundamental features are the building blocks for more complex representations. This layered approach allows the system to build an understanding from the ground up, much like how we learn to perceive the world. The depth refers to the number of these layers stacked upon each other. A deeper network has more layers, allowing for a more intricate and hierarchical representation of the data. Each successive layer takes the output of the previous one and learns to detect increasingly abstract and complex patterns. This iterative refinement is key to how deep learning models achieve such remarkable performance on tasks like image recognition, natural language processing, and more. Consider the progression of feature extraction. The first layer might detect simple lines and color gradients. The next layer could combine these lines to recognize basic shapes like circles or squares. Subsequent layers might assemble these shapes into more recognizable components, such as an eye, an ear, or a paw. This gradual buildup of complexity is what allows deep networks to discern subtle differences and identify sophisticated patterns. This layered abstraction means that each layer learns to represent the data at a different level of detail. The early layers focus on low-level, raw features, while the deeper layers learn to represent high-level, semantic concepts. This hierarchical feature learning is the engine driving the power of deep learning models, enabling them to make sense of vast and intricate datasets without explicit human programming for every feature. The arrangement of these layers is not arbitrary. It's carefully designed to facilitate this hierarchical learning process. Information flows sequentially through these layers, with each one transforming the data into a more abstract and useful representation. This structured flow ensures that the network can effectively build upon the insights gained from previous layers, leading to a robust and comprehensive understanding of the input. The magic truly happens in how these layers interact and learn from each other. During the training process, the network adjusts the connections between neurons in each layer to minimize errors. This means that each layer is not only extracting features but also learning how those features contribute to the overall goal, whether it's classifying an image or predicting a sequence of words. This ability to automatically learn relevant features at multiple levels of abstraction is a significant departure from traditional machine learning. Instead of engineers meticulously handcrafting features, deep learning models discover them autonomously. The depth of the network directly correlates with its capacity to uncover these intricate, hierarchical representations from raw data. So, when we talk about deep learning, the deep isn't just a catchy buzzword, it's a fundamental architectural principle. It signifies the presence of multiple processing layers, each contributing to a progressively refined understanding of the data. This layered structure empowers deep learning models to tackle problems of immense complexity by breaking them down into manageable, hierarchical stages of feature extraction. The power of deep learning, therefore, lies in its capacity to build sophisticated representations through a cascade of transformations. Each layer acts as a specialized filter, refining the data and passing on a more meaningful representation to the next. This depth allows the model to move beyond simple correlations and grasp the underlying structure and semantics of the information it processes. In essence, deep learning is deep because of its layered architecture, enabling it to learn and represent complex patterns through a hierarchical process of feature extraction. This sophisticated design is what unlocks its potential across a wide array of challenging artificial intelligence tasks, allowing machines to perceive, understand, and interact with the world in increasingly intelligent ways.